Hello everyone, in this video we are going to solve the problem number 1.70 from Irodov and that is related to dynamics. So let us first understand the problem and then we will solve the problem step by step. We are having the horizontal surface and the coefficient of friction between the horizontal surface and these masses are given as K. We are having two masses, that is 2m and m. One is the bar and another is the block with the motor system attached on it, and then a thread which is wound on the shaft of this motor and that is connected to the mass 2m. If we talk about the motor, then let us say this is the electric motor which has some support in the bottom, and then a coil is wound inside it and it is connected with the shaft. Okay, whenever we are supplying the electric power to this particular coil, then this shaft which starts rotating, so this is called the shaft on which we can attach another component. It may be fan or something else. So basically we have to find out the time instant at which both the masses will collide. So let us first draw the free body diagram of mass 2m. So let us say this is the bar of mass 2m. We will have the gravitational force in the downward direction, that is 2mg, and the normal reaction from the surface in the upward direction, and let us say it is moving in this direction with the acceleration given, that is w, and it is constant, and we are having tension force in this direction. Let us say T is the tension force acting at every point on this particular thread, and we will have the friction force of mu into or K into N in this particular direction because it is moving in this direction. So if we balance the forces in the vertical direction, as it has no acceleration in the vertical direction, so we can write N is equal to 2mg. Okay, if we write the forces in the horizontal direction, then we can write it as T minus K into N, that is mass into acceleration, where T minus K into N we can write it as 2mg, that is equal to m into w. So from here we can find that tension force in the thread is equal to 2kmg plus m into w. So this is the tension force we got. Now let us draw the free body diagram of this particular mass. So we can say this is mass m and it is moving in this particular direction with the acceleration, let us say w1. We are having the gravitational force in the downward direction, that is mg, and the normal force from the surface in the upward direction, that is, let us say n1. The tension force will act in this direction, that is T, and as it is moving in this direction, the friction force will act in this direction and the value is K into N1. So let us balance the forces in the vertical direction, that is N1 is equal to M into G, and in the horizontal direction we can write T minus K times N1 is equal to mass into acceleration. Okay, I think here we have missed it. It is 2m into w because it is having the mass of 2m. So this is 2mw. So here we can write T minus K times N1 we have found out, that is mg, is equal to mass into w1, and then tension force we can substitute from here. So we can write 2kmg plus 2mw minus kmg is equal to m into w1. So from here we can find the acceleration of this particular mass is w1 is equal to kmg plus 2mw whole divided by m. So from here we can get the acceleration is equal to kg plus 2w. So this is the expression of the acceleration we got. Okay, so now we are having the two body. One is having the mass of 2m which is going in this direction with the acceleration of w, and we are having another mass of m which is moving in this direction with the acceleration of w1, and the length between these two masses is given as L. Okay, so if we use the concept of the relative motion, then if we make this particular mass at rest, then the mass 2m will move in this direction with the acceleration of w plus w1, and it has to travel by the distance of L. So from the equation of motion, we can write S is equal to ut plus half into acceleration into t square. Here the initial velocity is equal to 0 because it is starting at the time instant of t is equal to 0, and the distance is equal to L, that is equal to half, and the net acceleration is w plus w1. So we can write w plus w1 into t square. So from here we can get t square is equal to 2L divided by w plus w1. So we can write t is equal to 2L divided by w plus w1 under root. So let us substitute the value of w1, that is kg plus 2w. So from here we will get t is equal to 2L divided by w plus kg plus 2w under root. So we will get time is equal to 2L divided by 3w plus kg under root. So this is the time instant we got at which both the bodies will collide. I hope the entire procedure is clear. Thank you.